Good morning. My name is Erik Rudin. I am Field CTO for cPacket, and we're going to go through another use case for Network Field Day. This one is a little bit different, but you get a general theme around MTTR, right? MTTR is different teams working together to solve problems. In this case, we're reacting to a customer who's unhappy. It could be Tom calling the help desk asking what's going on with the internet service. It could be us wanting to understand the quality of that application, right? It's a healthcare application, or it's a business application that drives my financial trading. And so if I'm a trader and I'm expecting a market data feed, I'm going, hey, what's going on? And so in this example, we're thinking about the user is now concerned, and we are acting as network operators in a reactive state. We're thinking about how we're going to go and get information, how we're going to look through the different logs and different data sets. But if we look at it initially, it looks fine, right? Everything looks good. This goes back to whose responsibility is it? And so is there a way that we can respond better? So Ron's going to walk you through this use case.
Thank you, Erik. Yeah, so I think the way to think about this one is the next level of user interaction, right? There is something that is happening in real time. You want an alert, you go to Slack. It's relatively simple to know what's going on. You have cases where you get the phone call, and this example is taken from a real life example of one of our customers, a big bank that has a relatively complex network. And the call that the network operation received was that people in a very specific branch were failing to access their remote desktop between 8 and 9. And then it didn't work again the day after. So if you look at the network, that's actual path, or relatively simplification of the path that it was taking. It was from a branch going to a colo, from a colo was going to a data center. In the data center, it was going through multiple hops to get to the remote desktop application, right? So trying and understand where this thing break took some time. And at the end of the day, what they discovered was that a box that was not supposed to be doing anything special, when acceleration device, was adding 300 milliseconds of latency around 8, and was causing people to basically fail the authentication. So it actually wasn't even a remote desktop issue. It was authentication, and it was along this path. So if you don't have monitoring points everywhere, then what do? Are you going to start replacing box by box, or how are you going to measure it? So that was kind of the use case, or that was the actual story that happened. And they did have cPacket, and they went through and basically found where the latency. So when they started, they knew that at some point the latency is getting to 300 milliseconds at the branch, but it took them a little while to figure out which of the devices along the path was adding the 300 milliseconds. What we want to show now is to say, okay, fine, you can do that, and we have all the dashboards, and you can go to the dashboard one by one and figure out where things are not working. But one of the things that we're seeing now with the introduction of AI is really the change in the user experience, right? People are doing it in a very different way, or at least it opens the tool to do it in a very different way, right? So we're going to double click a little bit on how we are seeing these use cases evolve once you add the ability to chat with the system, right? So it's not necessarily AI as So we're using these two terminologies, right? We're using AI for network observability, right? Which is, can I use AI to understand what's wrong? And we'll talk later about network for observability. So what we're really going to spend time is, yes, AI for network observability. We're going to see how AI allows me to understand what is wrong, but also how AI helps me with a workflow, or a natural language processing workflow. So what we did is actually recorded the video, and the reason we recorded it, we're a little bit limited on time, and it did take some time to do that. So what we've done is basically accelerated some of the session. So what we're seeing here, is the network operation guy received a call, and he said, "Okay, I understand. I cannot go to the remote desktop. We used here a different service just for our simulation called Acme." And what the user asked was, "Is there any insight? Is there anything you know about this service that is not working well?" Right? So the LLM went to our database of all the insights and said, "Yes, I do see things that are not quite right with this service." So then the user went there and asked, "Okay, can you give me a little more details around the exact, because I know that it's happening now, can you give me insights that are relevant to now?" Right? And again, the engine is going back. We have an MCP that sits on top of all of us. And he's saying, "Yes, I do see there is something that is client performance issues. There are jumbo frames. That's probably not the reason." So what the user asks is, "Okay, now I kind of understand what the insights are. Can you visually show me the difference between what I'm seeing right now versus the baseline?" Right? So we built the baseline, so we know how the system should behave around Tuesday at 8.
I have a question for you.
Yeah.
This is Aaron here. That baseline, you said you built it. Did you build it yourself, or is it just going to collect that over time? Or do you say, listen for 2 weeks and then tell me what it looks like, and that's the baseline? How does that work?
Yeah, that's a great question. So the way that our AI for observability works is we bring in all the metrics from all the devices to a storage, a big storage, big S3 bucket or big object store bucket. And then we have a machine learning AI pipeline that runs on top of that. And again, we're using different models, but one of the models is to create a baseline that takes into account every service, every time of day of week, every metric that we collect about 50 or so metrics per retransmission. So today, the baseline is done based on the first few weeks that it runs, right? As long as the idea is, because it's unsupervised learning, we're saying, well, if the first few weeks you didn't have any major incident, let's use that as a good baseline, right? If there are, we have to, subtract that. But that,
so if you're putting this in a green field or something like that, you wouldn't want to run it immediately, right? Because there's no load on it, right?
Absolutely. Yeah.
Okay.
We spend time learning and then we adjust as time goes by.
All right, thank you.
Sure.
So a lot of questions. If you're building a baseline, why not just start letting the user know about it proactively instead of
we'll
coming?
Show that a little later. I think where we are today, the truism, when we started with cPacket and started talking to network operation people, they said, "Don't give me alerts. I have enough of alerts," right? And if you have something very, very relevant, yes, tell me that. So really, the way that we approach it today is kind of crawl, walk, run, as in we identify an insight, but the level by which we will say it's an alert or you should now act on it is not there yet, right? So what we are showing now is, okay, we know about it. We didn't really surface it. We'll show in a second. There are ways we can surface it, become more proactive. But this one is like, okay, for whatever reasons, the engine did not think that it's worth telling the user or the network operation, but it's still there. So this is still a workflow that is similar to, I would say, I always kind of joke, I started in networking in the 90s, and I was working on a cellular speed 9600 kilobits per second, and I used Wireshark. People still use Wireshark. It was Ethereal then. People still use Wireshark to debug 400 gigabits per second. So I think this is just kind of showing how you get a little better, right? So you're able to still manually interact with the system, but instead of having to look through Wireshark log, you can start looking at graphs and ask to visualize the information. So it's a lot easier. So you still need to be a pretty sophisticated network engineer to understand what to look for. It's just a lot easier to be able to visualize it. right? So we have all the visualization today, and this is kind of what we were trying to show in the first case. The problem is that we have hundreds, and in a big enterprise, you'll get thousands of these relevant graphs, which is very hard to know which one to look at.
I actually appreciate you saying that you need a degree of knowledge in order to make it work, because I think there's a temptation with AI to make it the magic button about, hey, you don't need to have skilled people. They can just, they can just type in what went wrong and magic will tell you. And I appreciate the honesty that, yeah, you actually do have to have a clue what you're doing in order to actually get anything out of this.
Right. We certainly, I would say the vision is to get it to simplifying, simpler and simpler. This specific one, I still need to know, okay, I need to look on retransmissions and whatnot.
But I mean, is that goal really around getting to a point where then the expert comes in, right? You're never going to get to a point where you're solving it all the way to the end, where you're still going to have to call John and say, I'm looking at these packets, help me figure it out.
So I think the speed of innovation that is happening today is so fast that I wouldn't say never.
Yeah,
right?
Fair.
I see the sophistications of the sophistication of the understanding of the models just changing all the time. I had a meeting with one of the big cloud service provider that is also runs one of the LLM engines, right? And I complained that they didn't give me the right answer about something. And he said, which model did you ask? I was like, oh, it was, yes. So the question was, is it Friday? Or did they release something on Monday that is completely different, right? So today, every few hours, something can change dramatically. So I wouldn't say it will never.
Yeah, but there's like knowledge that John might have about his business and the way it works that is not in any kind of model that's out there, that those are kind of those intrinsic knowledge that we learn in doing our work.
Totally. So as we go to the next one, you'll see that in order to be more proactive and more predictive, you start adding more context. Such that the engine can understand that. And this is why it's so important. Sorry, what I was showing there, and I skipped that, is that effectively what the engine identified was that there was two different VLANs or two different locations that were showing the different latency, which pointed out to the fact that it wasn't actually a server issue. It was really between. So these are two locations in the network. So VLAN and VLAN 222, these are two different locations. So it really meant that the load balancer between these two was the one causing the problem, instead of being, like if you see this one, when I was close to the server, the latency was very low. And as I moved to the next one, the latency jumped. So what that meant was that if you're close to the server and the latency is low, and the next hop, the latency is high, the problem is in that hop, right? So it's really the difference between, is it a server issue or is it a hop? Or is it a network issue? And if it's a network, where in the network the problem resides?
Quick question. As far as the visualization goes, I like these graphs, and they're very informative. When you were showing us earlier kind of the network diagram where, hey, this was the path that traffic was sort of taking, is that part of the visualization as well, or was that? So is there a way to see the traffic flow and then the pinpoint, like, oh, by the way, not only am I seeing this on this side of the load balancer and this, but here's where it's located in your topology?
Yeah, so it's on our roadmap today. We still use that. One of the things we're using, again, AI for machine learning, we can use that interchangeably, is to be able to understand the network topology. And when we say the network topology, we mean both the logical. So if I have a client that is going over a NAT and is talking to a server, that's the logical, but physically it's actually client going to a NAT and a NAT or firewall going to the server. Or if you have a proxy, you have the clients going to the proxy and the proxy opens, or a load balancer, right? So being able to identify all these, yes, we're working on it. And then once we'll have that, we'll be able to also show that, but it's not here today.
Do you
Thank
see
you.
someday in the near future where, like in your situation, you're doing RTT analysis, right? Let's say the load balancer is operating in 4 to 7 range, and the delay is actually in a 4 to 7 logic somewhere. Do you envision the system being able to be smart enough, saying, "Oh, in this topology, look, it's a 4 to 7. I'm going to do a 4 to 7 RTT, a RAM type element test just to see what's going on," and then reversing out the logic from that?
Yeah, absolutely. So today we know how to identify them. I think where we are is being able to visualize it in an easy way. But once we have that, then yes, absolutely.
And how do you see the codification of that expertise? Right? Obviously, cPacket, with the employees and the experience that you have, has a certain amount of expertise in terms of that. Then you have the LLMs that's kind of really smart in some way and dumb in some way, right? How do you see the codification of the expertise? So you got the metrics, you got the LLM, which can do reasoning. Then you have this domain expertise in there. How do you see the codification of that? And how do you enrich that on an ongoing basis? And back to sort of Mike's question, which is, if you have domain-specific, very domain-specific, or even company-specific, unique insights, how do you embed that into the system so that we can actually get insights out of it?
Yeah, I'll show you, the third one will show that a little bit. But the idea is, one of the things you can do with MCP is to integrate that knowledge. So what we're seeing today is the users use the system, we collect the logs, we collect and then you kind of start seeing the pattern. So once you see the pattern, you can make it a kind of what they call a high-level tool, so that embeds that knowledge. So instead of kind of show me all the insight, I can say, and I'll give the example later, instead of saying, show me all the domain names, and then I need to find which one is suspicious, I can say, give me the suspicious domain names and integrate what is a suspicious domain name into the tool. And then you get one question and one result that is kind of more.
So the abstraction that the MCP is supposed to provide is you meet LLMs sort of halfway, so you count on the reasoning engine inside the MCP, inside the LLM, to be able to understand that if I give you these kinds of function calls essentially in our APIs in the MCP, that you will call the right ones to get the right insight. And based on what I tell you, that you can reason the next step. So tool use, and you have to sort of meet it halfway, right? Because you don't know, the LLM gets better and your MCP needs to provide the appropriate context.
Right. If you look at this, and the reason the demo took a little longer to go, there were a lot to run SQL.
Yeah.
So you want to kind of get away from the run SQL.
Yeah, that should be on this side, not on that side, because that's specific to the domain.
Exactly.
Right? Yeah.
Exactly.
Got it.
Great. Thank you for that. That was excellent. Couple of things just to highlight in that use case. First of all, it's really essential that we baseline, right? In this case, there was a ticket created by the user. The service was impacted during a certain period of time. But when we start seeing that pattern, the machine learning actually gives us that context. The other thing is essential is that we need the data, right? Data at the lowest level gives us the insight, and then we integrate that into the different processes. But when Ron was talking about the different systems that we have, every component of the cPacket architecture has a data store. And so this is the metadata store. This is the absorption of all the data from the different brokers and the different storage capture devices that roll up into that analytics layer. So it's not capturing everything across the entire enterprise. It's actually catching the session metrics and the observability metrics and then doing reasoning over that. And then, one of the things I would say, just to answer that prior question, is this is why workflow is absolutely essential. Workflow is human in the loop, right? AI assisted. I think that's really the essence of what we're talking about, is that it's a new tool in the toolbox, as Mark said in the beginning. But what it's doing is it's accelerating the triage process. And so from a business perspective, if you were to say, why is cPacket going to help this go faster? It's like, simply put, we're going to shorten the troubleshooting time, either mean time to detect, mean time to understand the context, which component, who to call. That means shortening your war room triage process, and then also integrating into your tool stack. So if you're using things like PagerDuty, Slack, if you're using ServiceNow for their agentic workflows, and this is where I think the industry is going. Agentic workflows are going to happen at different layers. There's going to be micro, and then there's going to be macro. And so in this case, could be both.